выступать. How QA. Я прошу его сделать ко-хостом. Значит, сейчас попробуем. Есть он в ко-хосте, пожалуйста. How QA. Good afternoon.
打的是 Wig 呀，
你好。
他后加位 is Kita 呀，欧金普利亚特呢。Thank you. Hello everyone. I'm Hou Jiawei from China. Very happy to see you. Please forgive us for our poor Russian. Our talk and communication will be in English with a bilingual slide.
Mr. Hou,
Thank you.
Can you please start your presentation sharing? Yeah.
能看见我屏幕吗，杨哥？
Yeah. Okay. We can see it. And now to demonstrate.
Today, I'm very honored to be here to share with you our team's latest research results on the design of an ankle rehabilitation robot. This is an innovative design based on TRIZ, with aims to solve some of the key problems in the current field of rehabilitation medicine. Our presentation was divided into the following sections: problem situation, problem analysis, problem solving, and evaluation. The first part is problem situation, which addresses the important role of ankle rehabilitation training. The prospect of development and the current problem are stated to identify the problems that need to be solved. Rehabilitation medicine, as an important part of the healthcare industry, is currently gaining momentum. Professional and effective rehabilitation training plays an irreplaceable role in persons' rehabilitation training and restoration of normal life ability. Taking the common ankle rehabilitation training as an example, there are several problems to be solved as follows. Many patients with ankle injuries and not enough rehabilitators. Labor-intensive manual rehabilitation with low treatment efficiency and variability in treatment exercise. Exciting ankle rehabilitation equipment with poor therapeutic effect and couldn't satisfy the individual needs. After defining the object of study and the problem to be solved, further analysis is needed. The MPV analysis of the ankle rehabilitation equipment has yielded a few key parameters of the ankle rehabilitation mechanism. The first one is versatility, which means can be used to rehabilitate people with different levels of disability. The second one is universality, which means the same equipment can be used for both right and left foot. The last one is flexibility, which means all the four multi-degree of freedom seismos movements allowing for with array or rate of rehabilitation exercise. Problems with the country technical system. Insufficient degrees of freedom for rehabilitation means does not satisfy torsion trimming in 3 axes for control of flexibility and angular range of motion. Low degree of automation of the device. Insufficient professionalism adaptation. Left and right foot interchangeability. Lack of necessary feedback. The common message of ankle rehabilitation at this stage can be categorized into manual rehabilitation and simple equipment rehabilitation. The video shows common methods of manual ankle rehabilitation. As we can see from this video, common methods of manual rehabilitation of the ankle rarely require a rehabilitation professional with experience in the different conditions of different patients. At the same time, a complete ankle rehabilitation session needs to be performed many times, and each time more than an hour. So, the manual rehabilitation has the following disadvantage. Time-consuming and inefficient. High labor cost. Labor-intensive. Unquantifiable rehabilitation exercise. The simple device rehabilitation has the following disadvantage. Per flexibility, per control of angular range of motion, low automation, insufficient individuals last adaptation, lack of feedback. The functional model degree is obtained from the functional analysis, from which it can be seen that damping rod branches and the bowheads within the system has excessive constraints on the support pedal, while the support pedal don't provide adequate support to the feet, while the bodies still have damage to the feet. This was followed by finding contradiction, which concluded that the biggest problem with the system was poor ankle rehabilitation, caused by poor feet, poor range of motion control, low quantization, and lack of necessary feedback. The founding contradiction shows that the problem can be solved at this stage by solving the over constituents of the ball hinge and damping rods on the support pedal, and by adding the necessary feedback immediately. Following the above necessary of the problem, we carried out further analysis and obtained a number of contradictions. For example, if adding airbag straps, then the factors harmful to the object are reduced, but the complexity of the equipment increases. If adding sensors, then device operability becomes better, but the complexity of equipment increases. If replanning solve electric actuator, then the degree of automation of the machine increases, but it increases the manufacturability of the machine. In this process, we got two solutions. Besides on the above a number of contradictions, the first one is reduce the number of damping bars. The second one is removing the ball hinge from the exciting unit and the support pedal directly through the vertical support bar. Technical contradiction. Solving is then used to solve problems for which no solution could be derived directly before. And beside on the improvement and deterioration parameters of each contradiction, the inventive principles that can be used are identified, and the corresponding solutions are given based on the inventive principles. Through technical contradiction solving, we came up with a total of 21 solutions, which include increased number of airbag straps and adjust the inflatable efficiency of volume according to the position of the airbag straps. Use a live instead of sensor for measuring angles. Combining multiple sensors with different rods. Reverse the direction of the jumping rod branches and add 4 support rods. In addition to the 12 pairs of technical contradictions, we identify 3 pairs of physical contradictions, such as whether to increase the number of sensors, whether to increase the inflatable bondage, and whether to increase the drive motors, after which we solve the problem using the method with result in 6 solutions. Using trimming, we cut out the ball hinge and vertical support rod from the system, resolving in 2 solutions. We make feather cuts to the remaining portion by cutting out the damping sensation and using a sparing instead. Finally, we cut all of the components except the support plate and came up with 2 solutions. We end up with a total of 34 solutions, not all of which had enough value. So we first evaluated all of them using ABC filtration to select the 10 most valuable of them. We used multi-percentile metric to score the 10 most valuable solutions using support left and right foot swapping. Low cost, no side effect, simple striker, and easy to operate as the scoring standard. Where 1 point for very good compliance, 0 point for good compliance, and negative 1 point for no compliance at all. By scoring them in this way, the 10 solutions are again differentiated, and the one that best meets our original design intent is choice. Then, we used ideal landscaping with the horizontal coordinate of rehabilitation effectiveness score to evaluate the 10 solutions that are cost-well. With the horizontal coordinate of 0 point meaning the best, and 10 point meaning the worst. And we can find out through the ideal landscaping that solution 8 is the one that scores the best. Therefore, we have made it the final solution and keep the other solutions as preparatory solutions. Our final solution is that ankle rehabilitation equipment be set on a 3 UPU parallel mechanism with a switching device for rehabilitation of the right and left foot. The U of the UPU means universal joint. The P of the UPU means sliding pair. The video shows the working principle of our final solution. the video clearly shows the working principle of the product and movement process. Our invitation, firstly, designing of the parallel mechanism for ankle rehabilitation equipment, solving an important problem for rehabilitation medicine industry. 3 Chinese patent certificate successfully applied in the industry and obtained good performance. That's all I have to say. Thank you for listening. Our program is still improving, and I'm looking forward to hearing your feedback and the suggestion. If there are any questions or ideas, I'd be more than happy to continue the discussion with you. Thank you very much. Спасибо.
Спасибо. Thank you, Hao Jiawei, for your speech. I thank you very much for your colleagues, to your colleagues also, to Han Bing, to Wang Jiyang, Jiang Su, and others. All participants who try to share us your work. Thank you very much for this multi-stage work. It seems that you applied the TRIZ-based projects during the whole stages, right? From problem solving to problem analysis to solving, and even to the verification and having the final product. The final product is very interesting and needed in the modern medicine. My question, before I switch to our colleagues, my question here is, have you considered the traditional medicine approaches or only the modern one? And maybe you have some experience of discovering such approaches, I mean, in the traditional medicine, in traditional Chinese medicine. Did they have some, I mean, did they use any TRIZ-based methods indirectly in such projects, in such applications, devices, approaches? Yes. Mike, you just switch on the mic, please. The microphone is switched off. The microphone is switched off. Cannot hear. Mr. Hao, yeah. Now, please.
Hello.
Yeah.
My English is not very good.
Maybe your colleague, Mr. Han, can answer such questions. Yeah, please.
Okay, Ramis, can you hear me?
Yeah, I hear you. Thank you.
Okay. I will answer your questions. Yes, your suggestion is very good, and in fact, it is under our consideration. But for the condition, for our condition, not this product we have not considered, but we will all still in progress for this thing.
So we had, thank you. We have some remark here in the chat from Mikhail Ruben. He said that yes, just to precise that the observed method is function analysis, not the function cost analysis. So
yes, maybe that is our wrong translation.
It's fine, just to clarify for our public.
Yeah. Okay.
Коллеги, есть ли вопросы нашим коллегам из Китая? Пожалуйста.
Да, спасибо большое. Можно, да, вопрос задать?
Конечно, пожалуйста.
Очень интересная работа, очень замечательный проект. И мы по нашему опыту, по крайней мере, да, знаем, что есть несколько этапов довольно стандартных выполнения проектов. Это постановка задачи, разработка концепций, верификация, внедрение, там, может, какие-то еще есть стадии. Можно ли выделить, какие стадии проекта были наиболее сложные и занимают наибольшие ресурсы, времени, трудностей вот из этих стадий? Понятен ли вопрос?
Sorry, Mr. Rubin. Can you repeat your question, please?
I
I couldn't catch it.
Maybe I repeated directly in English, so it's fine.
Okay.
Okay, the question was about the multi-stage projects of yours. You discovered the TRIZ-based project in multiple stages, right? So the question here is, what was the most difficult stage for you, and I mean for your team, during this project?
I see.
In terms of resources, expenses, and in terms of
okay. I see what you means. And in fact, in my experience, I think the most difficult for us is the prototype design.
Prototype design.
For that is for my design. Yes, everyone has his own opinions, but for myself, I think that is the most difficult.
So you have many options to how to implement this.
Yeah. And the second one is the demand analysis. That is very difficult.
Demand analysis.
By
the way, I have here another question. Михаил Семенович, у вас есть дополнение к ответу?
Да, спасибо большое. Это соответствует и нашему опыту. И здесь возникает тогда вопрос о том, как ТРИЗ может ли вообще помочь вот в тех вопросах, которые вы обозначили, верификация, анализ рынка и так далее. Да? То есть получается, что на разработку концепции с помощью ТРИЗ у нас уходит довольно немного времени, а основное время в инновационном проекте у нас уходит совершенно на другие, да, работы время. Вот мы, по крайней мере, рассматриваем это как некую проблему, которую хотелось бы решить, если удастся. Но получается, что и в России, и в Китае похожие проблемы, да.
Mr. Han, did you hear the answer of the comment of Mikhail Rubin?
Ramesh, what do you mean? I could not catch you.
Have you received the comment from our colleague Mikhail Rubin?
Yeah.
Okay, great.
I see what you mean.
Okay, great.
Okay.
So now I ask, пожалуйста, Marat. We have question from Marat Gafitulin. Please, TRIZ Master. Пожалуйста. Так, вы можете голосом. Марат, вас пока не слышно.
Сейчас слышно?
Теперь слышно, пожалуйста.
Спасибо.
Здравствуйте.
Прежде всего, большое спасибо за доклад. Такой обширный, детальный доклад. Это молодцы. У меня вопрос, предложение, наверное, в большей степени по развитию результатов вашего проекта. Вот если понятно, да, там я говорю. Стопа, она сама сложный механизм. Стопа сама, вся голеностоп сложный механизм. Когда я увидел конечный продукт, который вы придумали, то было связано с голеностопом, с суставной частью. Но так как в ходьбе еще участвуют пальцы, то я в вашем проекте не увидел воздействия на пальцы. То есть я думаю, что это одна из перспектив по совершенствованию того изделия, которое вы спроектировали.
Более того, если позволите, скажу еще, что участвует все тело, не только пальцы, наверное, и все тело, вся весовая составляющая, весь баланс тела, и то, где позиционируется спина там, и так далее. Мне так кажется, что и это тоже надо учитывать.
Да. Просто та подушечка, на которой нога лежит, вот передние пальчики, они свободные находятся, то есть там есть ресурсы для восстановительных процессов.
Mr. Han, maybe you have any comments on this?
Yeah. Okay. Margaret? Okay. Many thanks for Mr. Getterfriend. Спасибо. Yes, it's a very good suggestion, and we will consider it in our next generation for our product. Because this prototype is our first generation, and it is under use in some medical care and for the real case scenes. And we will all right, and we will review it and to considering for your suggestions on our next generation. Okay, спасибо.
Okay, thank you. We have one more question from Andrei. The patient is sitting or standing during the rehabilitation process. Can you please clarify?
Sorry. What does it mean? Because they speak Russian for patents.
Okay, the patient during the rehabilitation process, is he standing or sitting?
In what? Sorry, for our my poor internet.
Okay, once more.
Sorry, really
No
sorry.
problem, no problem. The patient during the rehabilitation process, is he standing or sitting? I mean, when he is using this device, is he standing or sitting?
Yeah. In my yes, I know it is sitting.
Okay.
Sitting or sleeping.
Or sleeping even.
Sleeping.
Okay.
He was sleeping on the bed.
Sitting. Lying there. Okay.
Sitting
Okay.
more. Yes.
Thank you very much.
Okay.
Actually, I have more questions, but we will put it in the chat. But now we are switching directly to our next. Thank you once again.
Okay. Thank you very much.
Our guest
Thank
from
you.
China. Good.
And
Yeah,
yes. Thank you.